Hello, I'm Tutor, and today we're going to be looking at the lungs from AQA GCSE Biology, Unit 3. So let's get started. Now here is a diagram of the lungs, and as you can see here we have the trachea, and the trachea is known as the windpipe. And here we have the bronchus, and the bronchus is the major air passage which diverges from the trachea. And it branches into even more branches, the secondary bronchi, tertiary bronchi, and then we've got bronchioles, which are the minute branches into which the bronchus divides into. The alveoli are in the bronchioles have lots of alveoli, and the alveoli are just air sacs. And an alveolus is just one air sac. It is a singular of the alveoli. And here we have the diaphragm, which is a strong sheet of muscles separating the thorax, which is your upper body, and the abdomen, your lower body. So like the stomach, the intestines, the liver. Now gas exchange. Here we have an alveoli, and in the alveoli we have air from the air into the lungs, into the alveoli, which are the air sacs of the lungs. And in this air there is a high concentration of oxygen, and in the bloodstream here we have deoxygenated blood, so there's a low concentration of oxygen here. So by diffusion, oxygen diffuses from the alveoli from a high concentration to the bloodstream in a low concentration. And carbon dioxide is the opposite. Carbon dioxide is in high concentration in the bloodstream and low concentration in the air. So it diffuses from the bloodstream into the alveoli. So how is gas exchange in the lungs made more efficient? Well, the alveoli have a large combined surface area where diffusion occurs. And the alveoli have a thin surface, 1 cell thick, so a short diffusion path, so diffusion can happen faster. So gas exchange can happen faster. And there's a rich blood supply, which allows for a steep concentration gradient. So the concentration gradient is maintained, because an oxygen diffuses from high concentration in the alveoli to a low concentration in the bloodstream, then the concentration gradient is no longer there. So that's why there's a rich blood supply. So when oxygen is diffused into the bloodstream, it is taken to the other areas of the body almost immediately. So the blood supply keeps refreshing. So rich blood supply, so steep concentration gradient, so diffusion always happens. So ventilating the lungs. Now in the diagram I showed you before, there was no intercostal muscles as shown here. And intercostal muscles are muscles between the ribs, and they're very important for ventilating the lungs. And obviously you have your lungs right here, and the diaphragm, which is also important in ventilating the lungs. So what happens when you inhale? When you inhale, your intercostal muscles and the diaphragm contract. And so the diaphragm flattens and the ribs move up and out. This increases the volume in the lungs, and so there is more space, so the pressure in the lungs decreases. And now the pressure in the lungs is lower than the pressure of the atmospheric air, the air outside your lungs, the air around you. And so this forces air in the lungs from high pressure to low pressure. Now what happens when you exhale? When you exhale, the opposite happens. Your intercostal muscles and your diaphragm relax. And so the diaphragm moves up and the ribs fall. So the volume decreases in the lungs, less space, so the pressure increases. And this forces air out of the lungs, because pressure in the lungs is higher than the pressure of the atmospheric air. So air moves out of the lungs from high pressure to low pressure. And yeah, that's basically all you need to know for the lungs. This has been the Awesome Tutor. Bye.